A variable frequency drive, or VFD, should not typically exhibit a secondary current reading that is twice the current reading on the line side. If such a discrepancy exists, it strongly suggests an issue that needs investigation. It's essential to understand the basics of current flow in a VFD system to diagnose this problem effectively. The line side current represents the current drawn by the VFD from the incoming power source. This current is influenced by the voltage and the overall power demand of the VFD and the connected motor. The secondary current, on the other hand, is the current that flows from the VFD to the motor. This current is directly related to the motor's load and speed. A VFD works by converting the incoming alternating current, or AC, power to direct current, or DC, power, and then inverting it back to AC at a different frequency. This frequency control allows for precise speed regulation of the motor. Ideally, the current readings on both sides of the VFD should be relatively close, considering the efficiency losses within the VFD itself. A significant difference, especially a doubling of the secondary current, points to a malfunction. Several factors could contribute to this unusual reading. Firstly, consider the possibility of faulty current sensors. The VFD uses current transformers or other sensors to measure current on both the line and secondary sides. If one of these sensors is miscalibrated or malfunctioning, it can provide inaccurate readings. To verify this, use a calibrated clamp meter to independently measure the current on both sides of the VFD. Compare these readings to the VFD display. If there is a significant difference between the clamp meter readings and the VFD readings, it indicates a problem with the VFD internal current sensors. Secondly, examine the VFD internal circuitry for faults. A component failure within the VFD, such as a capacitor, diode, or insulated gate bipolar transistor, can lead to distorted current flow and inaccurate readings. An overcurrent situation within the VFD can also trigger protective mechanisms that might influence the displayed current values. Inspect the VFD cooling system. Overheating can stress components and cause them to malfunction, leading to inaccurate readings. Thirdly, the motor itself could be the source of the problem. A short circuit within the motor windings can draw excessive current. This increased current demand could be reflected in the VFD secondary current reading. Check the motor's insulation resistance using a megameter. Low insulation resistance indicates a potential winding fault. Also, inspect the motor's bearings. Worn or damaged bearings can increase the motor's load and current draw. Fourthly, consider the possibility of harmonic distortion. VFD generate harmonics, which are unwanted high-frequency components in the current and voltage waveforms. These harmonics can affect the accuracy of current measurements, especially if the measuring device is not designed to handle them. A harmonic analyzer can be used to measure the level of harmonic distortion in the system. High harmonic distortion can indicate a problem with the VFD filtering circuitry or with the overall power system. Fifthly, check the VFD parameters and settings. Incorrect parameter settings can affect the VFD performance and current readings. Verify that the VFD is programmed correctly for the specific motor and application. Pay close attention to parameters related to motor voltage, current, and overload protection. Sixthly, examine the wiring between the VFD and the motor. Loose or corroded connections can create resistance and affect current flow. Ensure that all connections are tight and clean. Also, verify that the motor cable is properly sized for the motor's current rating. Undersized cables can cause voltage drop and increased current draw. Seventhly, consider the load in the motor. An excessive load can cause the motor to draw more current. This increased current demand will be reflected in the VFD secondary current reading. Check the motor's nameplate to determine its rated current. Compare the measured current to the rated current to ensure that the motor is not overloaded. Eighthly, investigate potential grounding issues. Improper grounding can cause circulating currents and affect the accuracy of current measurements. Ensure that the VFD and motor are properly grounded according to the manufacturer's recommendations and local electrical codes. Ninthly, analyze the VFD fault history. The VFD may have recorded fault codes that can provide clues about the cause of the current discrepancy. Consult the VFD manual for a list of fault codes and their meanings. 10thly, review the VFD installation and commissioning procedures. Errors during installation or commissioning can lead to incorrect settings and performance issues. Verify that the VFD was installed and commissioned according to the manufacturer's instructions. It's crucial to involve a qualified electrician to conduct a thorough inspection of the VFD and the connected motor. They can use specialized equipment and techniques to diagnose the problem accurately and safely. The electrician should follow a systematic approach to troubleshooting, starting with the simplest and most common causes. This includes visually inspecting the VFD and motor, checking wiring connections, and measuring voltage and current levels. If the cause of the current discrepancy cannot be identified through basic troubleshooting steps, the electrician may need to use more advanced techniques, such as analyzing waveforms with an oscilloscope or performing insulation resistance tests. In some cases, the VFD may need to be disassembled for internal inspection. This should only be done by a qualified technician who is familiar with the VFD internal components and safety procedures. If the VFD is found to be faulty, it may need to be repaired or replaced. The decision to repair or replace the VFD will depend on the extent of the damage and the cost of repair. In many cases, it is more cost-effective to replace an old or heavily damaged VFD than to repair it. When replacing a VFD, it is important to select a model that is compatible with the motor and the application. The new VFD should have the same voltage and current ratings as the original VFD. It should also have the necessary features and functions for the specific application. After installing the new VFD, it is important to commission it properly. This includes setting the VFD parameters, testing its operation, and verifying that it is performing as expected. Proper commissioning is essential to ensure that the VFD operates safely and reliably. In addition to troubleshooting the VFD itself, it is also important to address the underlying cause of the problem. If the current discrepancy was caused by a motor fault, the motor will need to be repaired or replaced. If it was caused by an overload condition, the load on the motor will need to be reduced. By addressing the underlying cause of the problem, you can prevent it from recurring in the future. Remember that working with electrical equipment can be dangerous. Always follow proper safety procedures and wear appropriate personal protective equipment. If you are not qualified to work on electrical equipment, consult a qualified electrician. A systematic approach, coupled with professional expertise, is vital to resolving the current discrepancy and ensuring the safe and efficient operation of the VFD and motor system.